In stats, we started looking at a two-way test for chi-squared. We have two variables in these scenarios. That's why it's called a two-way test. And notice when you look at this table here, we have one variable on the left, one variable on the top. Whereas in our last test, right here, we only had one variable. What month does their birthday fall in? So that was a one variable test. That was a GOF test. So we're looking at this two-way test, and depending on how the samples were taken determines if it's a homogeneity or independence test. So this one's homogeneity. The next one we'll look at is independence. This one, it's homogeneity if we have independent samples taken. If we're looking at independence test, we have one giant mixed sample. The name of the name of the test is the null hypothesis. So notice the name of this test is homogeneity, which is implying sameness, which is what we're testing in our null hypothesis. Or actually, we're testing if they're different in the alternate. But what I memorize is the name of the test should match the null hypothesis. So when we look down here at political affiliation and cell phone use, we see that we have independent samples taken, and down here it says differs. That, and then this right here are hints that we're talking about a homogeneity test. So those two things tell me which chi-squared test we're talking about. Let's go back up, look at the details of it, and then we'll work it. So you state that you have independent random samples. Expected values still need to be greater than 5. That's typed right here, except you find expected values a little differently. You want to take the marginal totals, multiply them, and divide by the grand total. But the calculator does it all for you. It's nothing to really worry about. I can show you how it's done, but we'll just let the calculator take care of it. Degrees of freedom, take your number of rows minus 1, number of columns minus 1, and multiply. Formula is exactly the same from the last test. Let's give this one a try. So I guess this research center is interested if phone usage is at all different across different political affiliations for people under 30. So let's write that, or something like that, in our null hypothesis. Type of political affiliation is the same for phone usage. This problem is pretty dated, talking about landlines. I don't think anyone has landlines anymore. These are for people under 30. So let's make sure we write that. For people under 30. And HA is the opposite. You can just write they are different. You already identified who they are, so you can get away with just writing that. They tell us what alpha is, so write that in there. And move on to the plan step. Oops, forgot to write. This is our state step. For the plan step, talk about how they were randomly taken. We have 2 random samples. And we need to check the expected values. So what I typically do, since the calculator does it for us, is I write expected values and I make a matrix, because that's what we're going to have to use here in a minute to find the chi-squared value. I make an empty matrix about the size of our table that they gave us. So notice up here in the table, I don't really care about these totals. I need a matrix that's 3 by 2 here in a minute. So my expected values will be a 3 by 2. So I just make an empty matrix. The calculator is going to do that for us here in a second. I'll show you how to do it by hand though if you're interested. Let's skip to the do step. The name of our test is chi-squared homogeneity. Remember, this is homogeneity test because we have independent samples taken. In the next problem, independence test, we have one big mixed up sample. That's an independence test. I like to write our formula. And let's jump to the calculator. So on the calculator, this is very different from GOF test, and that's what's confusing about this. GOF test, we use the spreadsheet. This one, we need to make a matrix just on a blank calculate screen. If you press this button just next to the 9, to the left of that catalog button right there, and then you press this button that's highlighted in blue, dead center, it lets you customize your matrix size. So I need to recreate that table that they gave us, and we want to ignore the totals. So I see we have three political affiliations. We have 2 types of phone usage, and we have our matrix. So type in your numbers. In this next part, I'd be really creative with how we come up with this. I think I actually had to look this up and how to do this, because when we run the test, it just asks for a matrix, and you can't type a matrix in the stat test option. So we could store this as a variable. If you hit Control and then var, see how it says store right above it? This arrow pops up when you press that, and you can store that entire matrix as one variable. So one more time, if you press, let me hit enter. When you have your matrix, if you press Control var, you get the arrow and pick any letter you want, and it's stored. Then you run a test like we always do. Stat tests. Go to two-way test. Don't pick GOF test, that's a one variable test. And I named my matrix A, and we're done. It even does degrees of freedom for you. It stores the expected values. We'll have to go find that here in a second. I'll show you how in a minute. So chi-squared. Well, I need that space. I'm going to scoot over a little bit. Is 3.2199. Degrees of freedom is 2. The p-value, I like to write it like this. It's the proportion of chi-squareds bigger than that chi-squared, which was not very small, 1999. And that is larger than alpha. So we are going to fail to reject. So ask yourself, does this give us evidence that they differ, or does it not give us evidence? If we're failing to reject HO, that means evidence does not suggest they differ. I'm going to run out of room here. Political affiliation and phone use differ. I like to leave that empty matrix back on the plan step because back when I scan back through my work, I see I have a big hole in my work. I need to go back in the calculator and find those. So press var on your calculator. This is after you've run the test. And there's our EXP matrix. Hit enter, and you got them. They all happen to be greater than 5. Whoops, there we go. So the conditions check out. All right, in the next video, we'll talk about an independence test.